viewer pane. All right, and we're going to be talking a little bit today about the first half of the presentation, data management, and the second half of the presentation where we're actually doing some coding, talking about measurement and networks. And we're going to talk about some very basic measures for networks. And like I said, in part one, first half of the presentation, we're going to talk a little bit about collection of data and important decisions that we make. We're going to talk a little bit about data quality and what we can do to mitigate potential issues when we are collecting data for network analysis. And then we're going to take a look at a guiding study, and we'll be doing some coding using data from that study. And then finally, like I said, that coding that we're going to do, we're going to look at three kind of very basic but essential measures for networks. Density of networks. So basically how many connections there are within a network out of how many possible connections. We're going to look at this measure called centrality, which gives you a sense of how centralized the network is. And then we're also going to look at something called reciprocity. So like the extent of reciprocity in our network. And these two variables, centrality and reciprocity, these are not only network level measures, so ways to put a number on how centralized the entire network is, but we can also look at the centrality of individuals. And there's many, many different ways to measure centrality, or different ways of thinking about centrality and how central a person is within the broader structure of the network. And if we recall from our previous Learning Lab 1 and from the intro over the summer, the reason network analysts care about these things is because based on network theory and a pretty large body of evidence, it's these relationships between individuals that are often, in a special context, even more important than individual attributes of the individuals. So factors like typical demographics we might collect about individuals, like race and ethnicity and SES status. Network theorists would argue like those are actually like synonymous with the networks in which these individuals are actually embedded. Also, like key to network theory is that like someone's position in a network, like how central they are, where they're located in a network, how many connections they have, like those can be things that provide those individuals opportunity, but also may place constraints on those individuals as well. So that's another reason why network analysts are interested in these measures and where people are located in the networks. And then finally, one other key consideration is these relationships between individuals. Depending on the context, they're often not static, but things that change over time as well. And one last thing I want to review before we move on is from Learning Lab 1, some basic terminology again. So you'll often hear me say node or actor. I use those interchangeably. Those are the individuals in our network. And then you'll hear me say things like ties and edges. Those are the things that the relationships that connect to those actors or those nodes in a network. And then finally, we'll talk a little bit, not in this Learning Lab, but Learning Lab 3, like other ways of thinking about networks too, and other levels of analysis, like group level analysis. But that's, we'll save for Learning Lab 3. So really quickly, we're going to talk about kind of two really, really important decisions when you're thinking about starting a network study that really really impact the outcome of your analysis and will like greatly change the metrics that you're putting together. Linda, I think you might have put a post in our GitHub site about one of the SNA case studies and interpretation of these metrics and whether the numbers are high or low. A lot of that can actually be impacted by these decisions you make at the beginning of a study. And one of the most important decisions that you can make is what boundary you're going to use for your network. Because theoretically, these networks could extend indefinitely. But one way to put a constraint on that to make it manageable to actually do network analysis is deciding like, what's the cutoff for who is going to be in this network, for who belongs in this network. And we call that boundary specification, or how we specify where we determine the cutoff is for who's a part of this network. And it can be based on a number of things. One is just like a person's position within a social structure. So for example, we might be interested in looking at teachers in a network, or we might be interested in our teachers in a school, or school leaders within a district, or a lot of network studies around use of Twitter, for example, might be individuals who use a certain hashtag, or individuals on Twitter but are part of a physical located structure, like students' use of Twitter, and setting the boundary for those students being like students in Wake County Public Schools or something. It could be event-based, so people who participated in a certain project or a certain event. Ours is kind of event-based, the network analysis that we're doing for those agricultural networks here at NC State and Cal Poly and University of Japan and other places. And that's effectively like who's a part of this. And we have like constrained the boundary for that network a little bit by restricting it to only those participants in that project that are actually being funded by the grant itself. Because if we don't do that, feasibly collecting data on every single person who might have been touched by that event or been a part of certain events within that broader project is just unmanageable and unfeasible. And then it can be other ways, but basically what I'm saying is like you have to determine and like make it very concrete who's a part of your network. The second really, really important decision is also identifying and being very specific about these relationships that you're connecting or that you're collecting information about between these individuals, like what that relationship is. And it might be more than one type of relationship that you're connecting for a network. So for example, again, that study that evaluation that we're doing for the agricultural networks, we're focused on like 3 types of relationships, basically. First one is who is co-authoring with other members of the network, because collaboration on publications is one of the outcomes for that specific project. Another is who is communicating with each other via this web-based platform that they have, similar to something like a online course. But these ties, these relationships between individuals, one way to think about them is not just the type of tie it is, whether it's a friendship or a co-authorship or an assignment partner or committee members, but also whether we want to collect information on how strong that tie is or how frequent those interactions take place. So again, like this is another really important decision that you have to make prior to the study in order to make data collection and data management feasible. So one last thing I want to talk about is sources of network data. A very common approach are actually survey instruments, especially if you're collecting data on a physical setting, like a classroom setting. And in that case, there are these things called name generators, or you might use a traditional survey, but you might have an item in your survey asking participants to like name who they're friends with in the classroom. Other ways of collecting data that's a little less prone to issues with data quality, which we'll talk about next, though, are things like discussion forum data that's information on actors in the network and their relationships that's collected behind the scenes and stored in places like databases. So for example, if you've ever taught an online course and you have online discussion forums and you might be interested in a network analysis of students who are talking to each other via these forums, all that information is actually stored in a database that you can untangle and put together and reconstruct into an actual network data set. So boundaries, relationships, and then figuring out where the sources are. And really quick, I've been doing a lot of talking, so I want to pause and hear from some of you all. So think about a network that you might be interested in studying or actually are studying. First question for the group is, like, what's the boundary of your network? How are you defining, like, what's the cutoff? Who's in the network and who is not considered a part of the network? And while you all think about that, I'm going to let my cat out because I don't know if you can hear him, but he's meowing. Just to warn you, there's probably going to be a dog that wants out soon too. All right, anybody willing to share?
I guess I'll share.
Oh, thanks, Melinda.
So the project I'm working on has to do with first generation students.
Mhm.
And we've created a peer mentoring program. So one of the things I want to do is look to see if peer mentoring actually has them engage more as we move down the pipeline from their freshman cohort to their sophomore cohort.
Yep.
So one of the things that I am struggling with is that our first generation group is about 33% of our incoming freshman class. So right now I have a group that's about 1,400 students.
Oh, wow.
So, I've been, one of the reasons I came back to listen in is to kind of try to think about how I can reduce that down, because we're looking at their co-curricular enrollment, right?
Yep.
And so you take 1,400 kids and you take that they've taken 5 classes their first freshman term, and all of a sudden the ties become almost unmanageable.
Yeah. So when working with the data, like well, there's all different types of ties or relations that you could collect information about. Usually bigger, yeah. Well, let's start with the simpler question first. So just to make sure I understand, like the boundary of your network is, in theory, those who are mentors. So I would imagine you're collecting, you want to know.
Nope, we're looking at the first generation's students in general.
Okay.
And then there are, so in the first cohort, they actually, so this is part of trying to assess the program as well, right? So in the first cohort, when they put this into play, they had to opt into the peer mentoring program. So there's the possibility that I can reduce it down to just those that were in the peer mentoring program. But the second cohort, you had to opt out of the peer mentoring program. So that second cohort actually is large. So, but I'm working with the first cohort just to start with. So I'm thinking of reducing it down just to those that are in the peer mentoring program, because that would probably make it more manageable.
Yeah, that probably will. And you would still be able to, I imagine like the outcome data is probably not an issue.
Well, it can be, because remember, I'm at an R1. So some of the courses, like freshman biology, there's 200 students in that, which means I'm finding like a lot of them are taking that particular course, that particular section, but then we also we can go down into the weeds, because some of the courses are lab sections, some of them are recitation sections, some of them are tutorial sections. So those are kind of some of the things that I'm struggling with right now.
Got it. We should set up a time, Linda, if you're interested. And
yeah, I was going to come to office hours. So
perfect.
But you were asking for somebody to volunteer and nobody else.
But I was going to ask you, like, what are the ties then? What are the relations that you're connecting? Like, is it?
Well, that's it. Are they registered in the same course or same section? We want to, what I'm hoping to see is that through the peer mentoring program, that over time, they become more connected.
Got it. So the relationship, we call these, I think, affiliation networks.
Right.
So the tie between individuals is co-enrollment in the same course then, basically.
Correct.
Okay. Yep. That makes sense. Well, that's actually much more feasible. I was a little bit worried if you're collecting ties like on, the number of like who might get together with other students like outside of school.
No. I'm just working with registration data right now.
Okay. All right. Well, much more manageable, much more feasible.
Yes and no.
We'll talk some more open office hours.
Yep.
I'll run through this pretty quick, but a lot of the same issues that you deal with in non-network studies are still very relevant. and issues you're probably going to be dealing with in a network study as well. Issues of reliability, for example. In some cases, like Melinda, if you're collecting data just from registration records, the records are probably going to be fairly reliable, I would assume. So like a student's enrollment in a given course.
Oh, absolutely. That's
yeah. But in some cases, if you're collecting data via like survey instruments or name generators, then those potentially can become unreliable or problematic. Think of something like this, like we might want to do a network study of like 30 students in a classroom, or no, like middle grade students at a middle school, and ask them about their friendships, asking them, even if we did it like 2 days in a row, like students might not be able to recall like everybody they're friends with, or I'm trying to think of actually a better example. Melinda, let's take your case. Let's say you weren't using registration records, but you were asking like on a survey that went out all these peer mentor students, asking them to recall who they had classes with that were also first generation students or something like that. That might cause an issue because it might be difficult for them to remember who those students actually are that they're in class with. But reliability, long story short, is definitely an issue. And I should have clicked on my slides more frequently because now they disappeared. Let me regenerate it. So I'll reknit it and zoom back into my viewer. But issues of reliability are still a concern in network analysis. And also issues of validity is still a problem. Let's say, for example, the way we phrase a question on a survey is intended to tease out like who people collaborate with, but the way it's constructed or the way we phrase it might not actually get at what we're trying to get at for that specific type of relation, like collaboration, which can be vague. We also deal with things like measurement error, but there are ways for working around this. So for example, like I was saying about those surveys or those name generators where we ask them to like recall who their friends are. If we're working with a smaller network, one way to deal with that is instead of asking them to recall by name or by memory, we can often just provide them with a roster instead and say, out of all these people, and this is what we do for our agricultural network, because it's a good sized network, but among the PIs and the co-PIs and the paid grad students, it's really not more than like 40 people. So instead of asking them to recall by name, we actually provide them with a roster, and then we ask them to identify like which people within this broader network of networks they've collaborated with along certain things. So we collect different types of ties. So like that's one way of dealing with measurement error. But long story short, I won't like dwell on this. Reliability, validity, measurement error, there's still things within networks that you'll have to deal with. And there's a good chapter, he talks about it, with Carolyn in the essential readings that I shared with you. There's a really good section on measurement error that I recommend you take a look at. But I'm kind of curious, Melinda, let's stick with you since you're actually doing a network study. Like, what are some issues to data quality that you might be concerned about?
I'm not really threatened by data quality because, well, I pulled the data myself from our IR tables. So I'm pretty confident that registration data is really reliable.
Okay. Oops, sorry, Kat wants back in.
I do love the Carolyn book, though, by the way.
The what?
The Caroline book.
Oh my goodness, yeah, it's so good.
I love that book. I was going to get a copy of it.
I'm hoping he's going to update it someday too, because it's getting a little long in the tooth, but it is a really good book, really well put together. And the data sets that he provides too, like I use those with my students, and it's so nice to have like data that's actually been used in studies to work with too. I'm kind of curious though, one last thing before we move on to the next slide, issues of data quality. Melinda, like, have you ever run into any cases where like a student might enroll and then drop, and then the record shows up like twice for that student? Is that something you have to deal with?
Well, there are flags in our data, so I can actually see if they're enrolled and whether they actually got a grade. So by pulling all of those particular fields, I can see whether they dropped and what the reasons were.
Okay.
That's institutional data. So I work with that a lot because I do a lot of DFR UW type reports.
Yep. Yeah, again, so like generally the type of data you're working with is like archival data. And ideally in many situations, that's really nice to work with just because that's something that's usually collected in a very standardized way that's been like refined over time. And that usually results in fewer issues with things like data quality. We're going to be taking, oh yeah, go ahead, Mona.
Also, I'm working on logged action data. So we are working on open-ended learning environments.
Yep.
Where students, working on problem solving or connecting with robots and training them on computational thinking, for example. And we collect several data in terms of logged action data.
Mm-hmm.
So also I'm interested to know how students collaborate in terms of number of actions,
Mm-hmm.
also their score or final project scores. So if you return again to the type of action like survey, I couldn't see something about logged action data. So also I tried to do some social network analysis, but all my trial failed actually.
Oh no.
So I will go to the official hours, but I'd like to ask here, there's any type of data in terms of logged action data?
Yeah, so when you say looking at how students are collaborating, is there a way for them within this open learning system for them to somehow work together? Like, for example, is there like a chat box or something where they can like chat back and forth about something?
Yes,
or
yes. So we have something like chat box and also something like Google Docs, where they share their projects together. And
got it. So the chat data, I don't know how it's stored like within the database system that probably is underlying this open learning platform. But there might be a way to like tease out who's talking with who. You could always do it manually too. If you
I'm more interested in who works with whom in which action, and also the number of contribution or number of participation from each student. So I will show this data in the official hour. So
awesome.
That's okay.
Okay, yeah, we'll talk about more office hours.
Yeah, sure.
Office hours will be right after this presentation too, so you won't have to come back at another time. So this was a study. This actually was an outcome of my dissertation research long ago. It feels like a long time ago. I guess it was 2014. But anyways, what we were doing is at that time at the Friday Institute, we were running these massively open online courses, which were professional development programs for teachers. But by massive, I say like maybe we had, I think in our largest course, we had about 1,200 teachers enrolled, and in most courses on average, we probably had about 200 teachers enrolled. So it's not like massive, like Coursera massive, where there's like 40,000 students taking a course or something like that. But anyways, we were interested in how teachers within this platform were using like discussion forums to collaborate and share knowledge and all these other host of things. So what we were kind of interested in this is seeing, first of all, we wanted to see part of the evaluation that we had to do for this project for the Hewlett Foundation, who was funding it, was we were arguing that peer support was kind of critical to supporting professional learning of teachers. And we had explicitly designed the course so that there would be opportunities and encouragement for working with other teachers and talking with other educators. So part of it was just looking at the extent to which educators actually use the discussion forums, and when they did use them, like what they actually use them for. So we are looking at basically like the extent of interaction between individuals in the discussion forums, and also the content of those interactions as well. But I'll go straight to some of the key findings. Basically, most of the interactions within these courses between individuals and educators were just single communications, often just one-way communications as well. Someone would post something, someone would reply to them, and then that was the extent of it through most of the course. What we found, though, is that even though there wasn't a lot of, let's call it dialogue, back and forth communication, one of the things that we did find in the qualitative analysis was the conversation was kind of constructed, evolved through multiple people's contributions to a discussion, as opposed to like back and forth between like two individuals. So that was really interesting as well. What we did find was there actually within our network there was a lot of reciprocity. So, and that was actually one of the sort of drivers, or one of the biggest predictors of who connected with who, was if I sent a message to you, it very much increased the likelihood that you were going to reply back to me. So that was like the study in a nutshell. You can take a look at it if you want to, but I only introduced it because we're going to be working with data from that study. So now is the time for the code along if you want to. There's no obligation to do it, but I'm going to show all my panes. And if you are following along, I'm going to recommend that you open up a new R script. And this is just a text file. It's an R text file. The R script is that we'll use to write some code. All right, so make this a little bit bigger. I don't need that much room for my script. So the first thing we need to do is there's quite a few packages we're going to need to load. So if you have the slide open, I'm just actually going to copy the code from the slides, and I'm going to run these packages. I'll run through these packages again. This janitor package is just it doesn't have a ton of functions. That basically I use it to clean variable names, which is very useful because data sets that I often get, I have like different ways of storing their variables and writing their names. So I use it for cleaning up the variable names usually. Tidyverse you should be familiar with. We use that quite a bit at the summer workshop. Tidyverse is actually a package of packages. So it has packages for data wrangling, packages for data visualization, packages for dealing with dates, packages for dealing with factor level variables, packages for a whole host of things. I'm also going to load the tidygraph package. If you remember from Learning Lab 1 or from the summer, tidygraph package is a sort of network version of ggplots. Actually, gggraph is the network version of ggplots. Tidygraph is sort of, it's the equivalent of dplyr in the tidyverse package, but it's a way for dealing with network data and network data management. So I'm going to load all these packages. If you're following along, you can load them too. Talk a little bit about the iGraph package because we didn't use it in the first Learning Lab. iGraph package is actually one of the, gosh, how do I say this? It's one of the original network analysis packages. Oh no, I got a frowny face. Is someone having some issues? Is it? Oops, I hope I'm not missing out on something on the chat. Let me see, hold on. Oh, didn't hear that. Let's see, Damji, I'm so sorry. Oh, sorry, mistakenly did that. Okay. Damji, are you good? Okay, excellent. So we're going to load these packages. The iGraph package, like I said, it's one of the original network analysis packages. I'm going to call it up though, because it does have some really useful, well-used functions for putting together some basic metrics for a network that unfortunately tidygraph does not have. Tidygraph is great for putting together actor level measures, like an actor's betweenness centrality or an actor's in degree or other measures of centrality. But for measures for the entire network, it only reports the very basics. So we're going to have those packages loaded. We're also going to load the iGraph package. So go ahead and type in that. So we're going to load library. And I've got the chat open so I can follow along too. Sorry about that. We'll load the iGraph package, and now we should have those 5 packages loaded. All right, next thing we're going to do, I'm not going to have you try to hand type this out. Oops, shoot, sorry. I would recommend if you have these slides open, just copying and pasting, but we're going to import our data into R. So I'm going to go back actually and look at my environment, and I'm going to clean this out. So we're going to start fresh here. I'm going to be basically importing two things. I'm going to be importing the relationships, the ties, the edges between individuals in our teacher professional development online course network. And I'm also going to be importing information about each of those educators, each of those teachers that participated in this network. So I'm going to run this and import these using the read CSV file because my data is actually stored as a, oh, I need to fix this actually. This data is stored in my lab 2 folder. So it's stored in this data folder. And because I'm working with an R script as opposed to the R markdown file, it's looking at the very top of my directory. And it's saying, oh, at the top of your directory, you don't even have a data folder. So I'm going to type in lab 2. And I'm going to say, look in the lab 2 folder, look in the data folder, and look for a CSV file called DLT1 edges and read this CSV file in. And as I read it in, I'm actually going to change some of the ways that data is stored to. So for example, our sender variable, the sender is the unique ID of the teacher who sent a message. It's actually stored as a number, and I don't want it to treat it as a number because these are like names of individuals basically. So I'm going to change some of these data types. So I'm going to run that. And all this that I'm talking about is actually explained in much more detail in our lab 2 case study too. I'm giving you like a very, very quick highlight of what we're going to do in the case study when you guys have more time to work on that, if you're interested in doing that. So now we can see I've imported my DLT1 edges file, ties filed. I'm going to import my actors. Oh, and I need to do the same thing. It is stored in the lab 2 folder and the data folder. And there we go. So if you've imported those, hopefully successfully, if you're following along, we can take a quick look at these. Let's look at our, first of all, let's look at the actors in our network. So we can see we have 445 educators in this network, 445 observations. So this is each educator's unique user ID. I've actually changed this. It's not the original ID that was in the system. I've recoded this for anonymity purposes. Also, we have information about their role. So I said teachers, but not everybody in here is a teacher. Some are librarians, some are classroom teachers, some are district administrators, some are in other educational professional roles. We have instructional tech folks, so a whole range of roles in this. We have their level of experience in education, and this is actually a range. So 1 means 6 to 10 years in education, 3 is 20 plus years in education. We have information about their location, so where they're from, what region, whether they're male or female, and then also some information that I've included in this data set about if they do this expert one. This just means that these people were specially invited into this course, and they were discussion panelists, basically. So they were invited guests. And this connect variable, what this means is that hold on. Go. I'm just going to leave that door open, and she can come and go as she pleases. All right, this connect variable is actually interesting though, because on the survey for registering for the course, we asked them actually if one of their learning goals for participation in this course was actually to connect with other individuals as well. So that's what that variable is. So those are the actors. And let me show you how we store the ties. Melinda, this might be of interest to you because as you're probably well aware, the data isn't spit out of the system into a nice edge list like this. We effectively had to reconstruct this data set from the way data actually is stored in the database. And we stored it as a standard edge list. So basically the way an edge list is stored, if you remember from Learning Lab 1, is the first column is typically, if it's a directed network, who's sending the message, in our case, in our context. And column 2 is like who's the recipient of the message. And if it's a directed network like friendships, for example, column 1 would be like who names who as a friend. So 360 would name 444 as their friend. And then we have information about these interactions of these individuals too. So for example, we have the actual content of their discussion. It's not included here because I couldn't do any data cleaning to ensure anonymity of all the individuals, but we have information about the discussion title that they posted, what group they were in, and they were grouped based on their location in the United States. So those are the ties too. So that's the data that we're working with. Any questions so far about the data? Linda, I'm kind of curious, as you're constructing your network data set, are you going to store it as an edge list kind of like this, or are you going to store it as a matrix? Oh, if you haven't got that far, that's okay too.
For me, like that, like with some little difference.
What's that, Mona?
Yeah, so I told you that I, for me, like that, like this file.
Like
However,
this file?
Yes, not in matrix form.
Yep, this is, so there's a couple different ways we can store it. Here, just a quick refresher, because this is kind of important. Lab one slides. Let me knit this. So here's kind of the edge list. This is basically the way we're storing it, where the first column is one person, the second column is the other person, and that's the relationship. Those are the two that have the tie between them.
So should I make it manually, or there's any way to make it automatically? So when I'd like to say that student 1 say something to student 2, so should I make it manually?
Oh, that's a good question. Let's talk about that at office hours, because it's going to depend on how you're exporting data from the system.
Okay.
And another way you can store data, I typically don't use this format, but another way you can store it is as a matrix. So we can see like 1 has a relationship with 4. In this case, this was student friendships. So student 1 named student 4 as their friend. Student 4, though, did not name student 1 as their friend, which is interesting. But anyway, so that's the distinction between the edge list and between the matrix. And those are the 2 main ways that you typically store network data. So let me knit this back again. Sorry about that. And all right, so we've got our data imported. We're going to wrangle it a little bit. Let me go back to my slide. So before we can begin actually analyzing our network data, we need to, we're going to basically, the nice thing about that tidy graph package is we have 2 files, right? We have edge list and we have our nodes, and we want the information about both of those things together. The unique thing about doing data with network analysis is you often will have 2 data files that are very distinct that actually can't be in a single data file. So what we do in network analysis is we often have to combine those 2 files into one data object. And this data object can be, there's different ways for naming it in R and different classifications for it, but it's basically a network object. And this network object contains information about the relationships, the edges, and it contains information about the actors as well. And it combines it into a single object. And that's what we're doing here, basically. This table graph function from the tidy graph package, it's going to say our edges, these are our edges, these are our nodes. Here's their like linkage between the twos. The user ID is what's connecting those 2 files. And we're going to tell it that it's a directed network too, because I can send a message to you, but you may not necessarily send a message back to me. So I'm going to copy that and I'm going to bring it over here. and we're going to make a new object in our environment. So we have our standard data frames, the actors and the ties, and we're going to make a new object called DLT1 network. And this will be a network object. You can see it over here. If I click on this and look at it though, oops, sorry, DLT1 network, you're going to see it doesn't look like a typical data frame. All this information is stored effectively as a series of lists in a very unique way. But if we take a look at what type of object this is, I'm going to go down here and say, hey, what type of object is this? I'm going to use the class function. And it's going to say, oh, this is a iGraph object or a table graph object, which is a special type of network object that combines our nodes and our edges together into one thing. So, but the nice thing is, if we type the name of this and just take a look at it, it's going to give us information about our actual network. So it's saying this is a table graph object, and that there are 444 actors, and in our network, there's actually 2,529 edges. So if we think of edges in this network as communications or forum posts, there's basically effectively 2,500 forum posts. And we also have information about whose post is to who. So when we look at the network object, we can get some information about that object already. It also tells us that it's a directed multi-graph and that there's 4 components. And when we get into talking about in Learning Lab 3 group level analysis, a component is basically a simple way of defining different groups in the network. So groups that are connected, where somebody is connected to someone else in the network, and groups that are kind of isolated. We'll take a quick look so I can illustrate this, but actually let me show you really quick. So if I do a quick autograph, and autograph is a function for making a very, very quick and dirty network graph using the gggraph package. So if I do that, we can see that here's my network, this big hairball plot. Most people are connected to someone in the network, but we have 3 individuals in this network that are not connected to anybody. So we have 4 components in this network. All right, so we've wrangled our data. Now we're going to talk about 3 measures, and we have 10 minutes to do so, and I think we can get it done. First measure is something it's pretty important, a pretty common measure in network analysis, and it's called density. And one way to think about density is basically like how many connections are in your network out of how many possible connections. And the more connections in a network, the denser the network. So it's a way to put a number on like the level of connectedness within your network. So take a look at these 2 random networks that I got a picture of. Which of these 2 networks is denser? Which one would have a higher density measure? And you can type it in the chat or you can just say it out loud.
The one on the right.
The one on the right. Yep, that one's way denser than the one on the left. Has way more connections in it. In fact, actually, I think this would be a density of 1.0 because it's completely dense. I'm sorry, everybody in that network is connected to everybody else in the network, which you will never, ever, ever see in the real world. The importance of this measurement, though, is density within educational network studies has been associated with things like the health of a community or flow of resources within a network, or even like denser groups associated with things like student achievement as well. So actually, Melinda, with your study, you might see, or one outcome of your study might be that as the students over time, as those co-enrollment in courses, you might see emerging in your network like groups of students that are more tightly connected to other groups. And those groups of students would be more densely connected. And there's a way to put a measure of density on specific groups as well. And you might theorize that among those students with more tighter connections that are co-enrolling in courses together, we might see better grades for those students because they know each other and have formed relationships over time and might be supporting each other as well.
That's the goal.
So anyways, iGraph has a function for measuring density within a network. Gosh, Melinda, you've sort of discovered this already. These measures that are being outputted are contextually based. Like a single measure, one measure in one context might not be interpreted the same way, the exact same measure in a different context as well. And by that, I mean, like let's think of our measure of density. If it's a small network, like maybe only 10 individuals, you might be looking at a small classroom. It's very likely that density for that classroom is probably going to be a little bit higher than a classroom of 40 students or 50 students or students within an entire school. So interpretation of these networks is kind of relative, to be honest. But we can't put a measure on density. So basically, there's out of all possible ties in this network, how do I interpret this? A fairly simple interpretation of this one, though, is that out of all the possible ties in the network, there's only like 1.27% of ties that are actually present in this network. So a pretty low density for this network. And you can interpret this as a percentage or proportion of all possible ties in this network. So if we look at this, this would be basically 1.0, 100%. All ties that are possible are present. So that's like the measure of density in a nutshell. And it's a way to put a number on how connected a network is. It's very basic, but it's also very common and something you'll often see in network studies. Any questions about density so far?
I
Go ahead.
I have a question. When I look at this one, there is just 4 components, and there is 3 dots over there, right? What if this 3 in the? Can you see that down there's 3?
Oh yes.
Yeah. Yes.
Yep.
So your data have 4 components. 4 groups.
4 components. Yep.
Yes. What if it still looks like outlier? So what if we remove these 3 components? I think the density will be increased, right?
That's right. If you were to remove these isolates, it would change the overall density. Probably by a fraction, just because there's so many people in this network. But right, and that's a decision you would make too. Actually, it's not uncommon for network analysts prior to doing modeling to actually remove isolates. It's almost like removing outliers, basically.
Right. So your data this data is for our meeting, right?
Yep.
I see. Okay.
Yeah.
It's not common to this type of 3 outlier or something. Network usually they connected.
Yeah, when we looked at Learning Lab 1 in the classroom friendships, we only had 1 isolate, 1 individual. But it's often, depending on the context, it's often very important to keep them in, because in that case, like if we were to use that network analysis to share with the teacher to provide some possible interventions for students, it would be really important to know that student, not only no one is naming them as a friend, but that student is not naming anybody as a friend either. So that student might be at risk of falling behind in class, or at risk of mental health issues, or whatever it happens to be. So, and that is another important decision that you make too, not only who is in your network, so the boundary specification for your network, but also when you do analysis, who do you keep in the analysis for your network? Because like you said, Samni, removing individuals from the network can change these network measures, in some cases dramatically if it's a smaller network.
Okay, thank you.
Yep. This one's kind of a trick question. So centralization is another key measure in network, and there's like 20 different ways to think about and measure centrality in a network, both at the network level, but especially at the individual level. So we have those same two networks here. We know this one is denser than this one. But which of these networks do you think is more centralized? So centralization is basically the extent to which relations are focused on one or just a small set of actors. So these two networks here, which one do you think is more centralized and will have a higher measure of centrality?
Left.
On the left, some of you got it. This one is way more centralized. Basically, everybody's connected to, let's see, 3 people, but this person in the middle is connected to everybody. So this one is much more centralized. And out of each of these individuals, which individual do you think has the highest centrality scores?
Oh, suddenly I have a question. If its data is collecting from classroom, that person looks like a teacher.
It could be. Yep. If this network in our boundary specification, if we said we're going to collect information about the individuals, the students and the teachers, it could be a teacher. Yeah.
So when we calculate the centrality, do I need to keep the teacher or do I need to remove the teacher interaction?
That's a good question. If the relationships that you're collecting are if the relationships you're connecting are not just between students, but between students and the teacher as well, you would want to keep them. In this case, though, this would be like, let's say Melinda's study that she's doing, where it's an affiliation network. I'm trying to think. So all of these students, like this person might be enrolled with this one, and this person might be enrolled with this one. But all 3 of those students all of these students are enrolled in this teacher's classes. When we have networks like that, where it's like 2 distinct type of different relationships, those are sometimes called bimodal networks. And there's whole different ways of doing network analysis with bimodal networks. But if the only relationship you're really interested in is the relationship between the students, then I would remove the teacher entirely from the analysis.
Okay.
Yeah, but this one is definitely more centralized. This one is very decentralized because there's no single individual that has more ties than anybody else. Sometimes this person in the middle, it's called it's a measure of, sometimes you'll hear the word like popularity in network analysis, like popularity scores and things like that. But this one would be more popular than everybody else in the network. And just like with the degree, there's a way of measuring degree for individuals in the network too. So we can get a measure of centrality for the whole network too, just like we had a measure of centrality for, measure of centrality for density, or a measure of density for the whole network too. So the centrality measure is interesting in that it will give you, basically the way to interpret this, each of these numbers represent an individual in this network. And this is how many people that individual is connected to. So this person is connected to 117 other individuals in the network. And this person is only connected to 1 individual in the network. And Sanmi, remember our 3 outliers or 3 isolates?
Yeah.
Those are those 3 individuals.
I see.
And they're connected to nobody. And we can also get basically a centrality measure for the entire network as well. So this would be 0.64. Interpreting these, I think the best way to think about these is using them for comparison between networks. So I might be interested in seeing if one course is more centralized than another course. Oh, if you need to leave, take off. Tom, thanks for joining us. Take care. And don't hesitate to reach out if you need anything. All right, and we're going to do our last one, reciprocity. Reciprocity is the very last thing. And right now, oh, Tracy, you need to leave too. Not a problem at all. Reciprocity, the very last thing is, this is a way for, and right now we're only talking about network level measures. So how do we put a number? How do we describe numerically the whole network? And we can describe it by the level of connectedness with density. We can describe it by how centralized it is with the centrality measure. And we can also describe it by how the level of reciprocity in a network. And by reciprocity, we mean that in our case with the teacher ties or the educator ties, if I respond to you, do you respond back? So the ties, are the ties two-way or just one-way? And we can put a number on the extent to which there's reciprocity in our network as well. And just like the other ones, there is a reciprocity measure. And we can just add that to our console. I guess I should have been doing this up here in the source. So the reciprocity of our DLT1 network. And we can get a measure of reciprocity for the network too. So about 20% of ties in this network are reciprocated. So again, like these are just measures, ways of putting a number or describing numerically like what the structure of the network. And in network studies, you'll see these measures all the time. So you should now be like a little bit more familiar with them if you come across them in studies. So that wraps up actually basically our learning lab part of the presentation. We'll move into the office hours in just a second. I just wanted to point out that at the end of the presentation and in our essential readings in our GitHub sites, I've included the 2 chapters that have information about what I talked about today. So if you're interested in these topics and going in greater depth, I recommend these 2 chapters, one for collecting and managing network data, and then one for measures for complete networks. And then also, if you want to practice those things that we just did in the presentation, there's also a case study here, which will walk you through all of these things in much greater detail and all of the code. And you'll basically do like a little analysis using the data and kind of replicating what I did for the MOOC stuff too. And then that's a link to our guiding study as well. So any questions before we head into office hours about the Learning Lab? Susan, thanks for coming. I appreciate it. Take care. And if you all need to hop off, go ahead. And Melinda and Mona, I think you wanted to stay on, or Sunmi, maybe you wanted to stay on too for office hours to talk about some network studies that you guys are doing. And I'm going to stop sharing, and I'm also going to stop recording too.